Hello, we're going to work on the solutions to your review. The first question says, given the function f of x equals x plus 2, we're going to graph it and check out the limit as it approaches 4. So we're going to go to our calculator, we're going to go ahead and press y equals, and under y equals, we're going to put x plus 2, and then we're going to go ahead and hit zoom 6 to get that standard negative 10 to 10, negative 10 to 10 window. When we graphics, notice a couple things. The y-intercept is 2, and we're going to look at 1, 2, 3, 4, and then it goes to 6. So we'll kind of, try to make it the best we can. Doesn't have to be perfect, but just give it a few reference points. Okay, and do the best we can, and that'd be perfect. Okay, and what we're going to look at is the limit as we approach 4. So here's 4. And as we come from the left, following the graph to the left, it is approaching 6. Okay? Now, approaching 4, x approaches 4 from the right, the y value is 6. And since from the left and the right are both 6, then the limit as x approaches 4 is 6. And then if you actually put 4 into the function, 4 plus 2 is 6. Okay. Then, are there any vertical asymptotes? The answer is no. Remember, if we're looking for vertical asymptotes, we'd have a rational function, something over something. So we're not going to divide by 0, so we don't have to worry about vertical. And then horizontal is also no, because remember, there's 3 rules for horizontal asymptotes. If we have a rational function, a function over a function, if the degree is larger, smaller, or the same, we don't have anything being divided here. So don't worry about that. And is the graph continuous at 4? Yep, at 4, there's no holes, no jumps, something. So yes, it is continuous. Okay. Next question. We're going to graph the function absolute value of x over x. So if we go to our calculator, go to y equals, clear the old one. Now for absolute value, we're going to hit math to the right for number, and we're going to do absolute value of x divided by x. Okay, then again, same window, so we're just going to go ahead and hit graph. We're going to go ahead and hit graph. And again, we're going to draw it the best we can. So it looks like this, the best we can. Okay. Now, as we approach 0, the limit as x approaches 0, so here's 0. Coming from the left, the y value is negative 1. Coming from the right, the y value is 1. Those do not match, so we're going to put DNE for does not exist. And then when you try to plug in 0, if you plugged in 0, can't divide by 0, that would be undefined. That would be undefined. Okay, and then do we have any vertical asymptotes? The answer would be, again, vertical asymptotes, 1 makes the denominator 0, so yes, and that would be at x equals 0. There would be no horizontal asymptotes, so if you look at the degrees, nothing happens there. And then is the graph continuous? No, there's a jump. Notice it goes from negative 1 to 1. There's a jump there, so it is not continuous at 0. Okay. The next one we have 0.2x squared over x minus 5. A little tip here, make sure we put the denominator in parentheses. So we're going to go to our calculator, go to y equals, clear the old one, and we have 0.2x squared divided by parenthesis x minus 5, close parenthesis, hit enter. Graph. Okay, we have something that looks like that. Note that at 1, 2, 3, 4, 5, 6, around there, that's where the change happens. So we'll do our best to kind of draw it. Doesn't have to be perfect. Do the best you can here. Okay, so again, the focus is on 5. So coming to 5 from the left, this is approaching all the way down, down, down. That would be negative infinity. Okay. Then coming from the right, notice as we approach 5, it goes up, 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 up. That would be positive infinity. They do not match. So that would be does not exist. And if you try to plug in 5, 5 minus 5 is 0. Nope, undefined. Okay. Now remember, for your vertical asymptote, we look at the function. What would make the denominator 0? That is 5. So yes, there is a vertical asymptote. You can see it. And it's at the equation x equals 5. Now for horizontal asymptotes, if you look at the degree of the numerator, is 2. The degree of the denominator is 1. Since the degree of the numerator is larger than the denominator, there are no horizontal asymptotes. So we don't have to worry about that. And then is it continuous at 5? No. Notice at 5 there's a vertical asymptote. It's not continuous. It goes down, it goes up. There's a big gap there. That gap is a vertical asymptote. So is it continuous? It is not continuous. Okay. Next one we have x minus 2. Again, put that in parentheses. Over x squared minus 4. So we go to our calculator. We're going to go ahead and hit y equals, clear what we have there. And then we're going to put in parentheses x minus 2 divided by parenthesis x squared minus 4. Hit enter and graph. And you're going to notice that negative 2, something's going on there, right? So go down here, it goes down. Over here, it's going to go up. Okay, so remember our focus is negative 2. So as x approaches negative 2 from the left, this goes down forever. Negative infinity. Coming from the right, it goes up forever. That'd be positive infinity. They do not match, so it does not exist. And you can't plug in negative 2 because we have a vertical asymptote there, right? They're in there. So a couple things that we want to point out. Remember, it's always a good idea to simplify first. So this would be x minus 2 over x minus 2 over x plus 2. So initially, if you thought maybe there's 2 vertical asymptotes, there's only 1 in the graph. And the reason why there's only 1 vertical asymptote is this simplifies to 1 over x plus 2. What makes the denominator 0? Negative 2. So is there a vertical asymptote? Yes, there's only 1, and that's at x equals negative 2. Then for horizontal asymptotes, what we look at is the degree. So the degree of the numerator is 1. The degree of the denominator is 2. So yes, there's a horizontal asymptote at y equals 0. And we can see that here. Okay, so is it continuous at negative 2? Nope, there's an asymptote there. So it is not continuous at negative 2. Okay, so our next one, we're going to have x squared plus x minus 2 over x squared minus 1. Again, we want to make sure that we put parentheses around that. So if I go to the calculator, go to y equals, clear what's there, in parentheses, x squared plus x minus 2, close parenthesis, divided by parenthesis, x squared minus 1, close parenthesis, enter, and then hit graph. Notice that negative 1, you can see what's going on there. So it looks something like this. Okay. Now, when we go through our things from negative 1, this is what we're approaching. Coming from the left, this goes down forever. So that would be negative infinity. Coming from the right, this goes up forever. That would be positive infinity. And since they do not match, does not exist. And we can't plug in negative 1. It's undefined because something's going on there. What's going on there? Again, we want to make sure we simplify first. So the top is going to be x x minus 1. Let's put x plus 2, x minus 1. And then the denominator is going to be x minus 1, x plus 1. So this simplifies to x plus 2 over x plus 1. So what makes the denominator 0? So yes, there's a vertical asymptote. It's at x equals negative 1. The degrees are the same. So yes, there's a horizontal asymptote, and we take the leading coefficient. 1 over 1 would be 1. So we can see that there is a vertical asymptote at x equals -1, and there is a horizontal asymptote at y equals 1. That's questions 1 through 5.